Hello friends, in this lesson we continue looking at vector geometry and how to solve questions on vector geometry. So our question for this time is what we have here. In the diagram below, OA is equal to A. So from O to A we have A. OB is equal to B. So from O to B to here, okay, you have to be very careful here. So from O to B here we have B. And C on AB is such that AC to CB. So AC to CB is 2 to 1. And B on OD, yes, B on OD is such that OB to OD is 1 to 2. Okay, so express as simply as possible in terms of A and OB, AB, AD, and CD. Okay, so we are going to start with our first question. Which is AB. We are finding AB. So here is AB, and that is going to be our first question. So we are going to write the formula for AB. So AB is equal to AO plus OB. Okay, so the question says find AB, meaning start from A and move around the object and then go to B. So you are starting from A, you have to move around the object. So from A to O and then from O to B. That is how you move. You can even move from A to D and D to B, but the problem with that is that here you don't have a vector on AD. And on DB, you can find it, but you still do not have a vector there. So use what you have to find what you don't have. So AB will be equal to OA, to AO plus OB. Okay, so now one thing that you notice here is that what we are given in the question is OA. And our formula here is showing us that we should use AO. So we have changed the direction. We are going against the arrow. The arrow is pointing in this direction, and we are going the other direction. So we have to put a negative sign to show a change in direction. So we have negative A plus OB has been given as B. Okay, you can leave it like this, or you can write it as B minus A. Okay, so that is our vector for AB. The first question, which says find AB, that is how we find it. We write the formula for that vector. So we go to question 2 now. Question 2 says find AD. Find AD. So we are finding AD. We are finding here from A all the way up to D. So this is the one that we are finding. So now for us to find AD, we are going to write the formula. The formula will be equal to, remember, if the question says find AD, you always have to start from A. So your formula should always start with the first letter that you have here. So you're going to have A, and then from A you go to O, plus, and then you start with the letter that you end with, O, until you reach the letter that the formula has here, D. Okay, so we can use OD because there's a ratio for OD here. So we can find OD by using this ratio. So before we substitute anything here, we have to find what OD is. Okay, so remember we are given OB. We are given OB, and therefore it means we can find the OD. So OD is the total length from O all the way up to D there. And so the way we find it, since our ratio is given as OB to OD, it's given as 1 to 2. So what we are going to do now is we already have OB, it has been given, so we are going to replace it. So we are going to have here where there's OB, we are going to have our vector for OB has been given as B. So we are going to have B here, and this side we are going to have OD. Okay, so where there is OB here, you replace it with B, and this side the OD remains. So the ratio is still 1 to 2 here. So we can cross multiply here. We can cross multiply here, and then we are going to have OD is equal to 2B. Okay, so we have found OD here by cross multiplying here. And so therefore, our vector AD is equal to AO, which is negative A, plus OD, which is 2B, which we can also write as 2B minus A. Okay, so this is how we find our AD. So now we can go to our third question. We are going to question 3, which says find CD. Find CD. So question 3 here. Question 3. CD. Okay, so CD here. For us to find CD, we are going to move CB plus BD. So we are going to have CB plus BD. Okay, so we can find both of these. We can find both of these because we have ratios. For example, we can find CB because we have this ratio here, AC to CB. Now, for us to find CB, the first thing that we do is to add the ratios, because C is found in between A and D and B. It's found in the middle there. So since the ratio is 2 to 1, the first thing we are going to do is to add 2 plus 1. We are going to get 3 as the total. And so CB will be equal to, now when you look at our ratio here, CB is represented by 1. So we are going to have 1 over 3, which is the total, multiplied by AB, because C is found between A and B. So we are going to put AB here. And so we are going to have 1 over 3 times AB. So AB was found in the first question. AB was found in the first question. Here it is. It's B minus A. B minus A is our AB. So we are going to have here B minus A. And then when we multiply, we are going to have 1 over 3 B minus 1 over 3 A. So this is our CB. So the next step now is to find what BD is. We have to find what BD is. So the way we find BD, the way we find BD is something that is not very difficult, because we already have the total OD. We found OD. Here it is. OD is 2B, and then we also have from the question here OB. We have OB here, which is just B. So for us to find what BD is, we just subtract the 2, the total minus OB. So we are going to say BD is equal to 2B minus B, which is equal to B. Okay, so BD is equal to B. So now that we have BD and we also have CB, we can substitute there. We are going to say, therefore, CD is equal to, our CB here has been found. It's 1 over 3B minus 1 over 3A plus B, because BD is just B. And so here we can correct like terms. So our like terms here are going to be 1 over 3B plus B minus 1 over 3A. Okay, so we can find common denominators here. Common denominator here, we have the denominator of 1. The common denominator here will be 3. So 3 into 3 is 1 times 1. You're just going to have 1 there. So you have B here. Plus 1 into 3 is 3. 3 times B there is 3B. So when we add, we are going to, so our answer for CD is equal to 4 over 3B minus 1 over 3a. And so this is our answer for CD. Thank you for paying attention.